Now we do part 2 of question number 1A of DU 2020 Introductory MME 1. Is the given function continuous everywhere? Is it differentiable everywhere? Now, whenever we have a rational function where the numerator is a polynomial, the denominator is a polynomial, the function is continuous and differentiable everywhere except, so the function is continuous and differentiable everywhere except when the denominator is 0. So therefore, 2x minus 4 equals to 0 gives us the point where there will be no continuity and differentiability. So you will say no, no. The answer is the function is continuous and differentiable on the set of real number minus the point 2. The third part, find the regions of increase and decrease of y. So now we should be knowing what is the region of increase and decrease of y. So basically, if we look at the regions of increase, a function is said to be strictly increasing if y dash is positive, strictly decreasing if y dash is negative. Okay. It is increasing if y dash is greater than or equal to 0, and it is decreasing if y dash is less than or equal to 0. So now, to know the region of increase or decrease, we should be calculating the first derivative. So y dash will be 2x minus 4 square. So we are calculating the first derivative using the quotient rule. So that is going to be 2x minus 4. The derivative of the numerator x square minus 3, which is 2x. Then minus the numerator, the derivative of 2x minus 4, which is 2. So then if we solve it, it should be 4x square minus 8x minus 2x square plus 6 divided by 2x minus 4 whole square. So y dash would be 2x square minus 8x plus 6 divided by 2x minus 4 whole square. So y dash would be 2 divided by 2x minus 4 whole square, x square minus 4x plus 3. So y dash is 2 divided by 2x minus 4 whole square, x minus 1, x minus 3. Okay. Now, the derivative, the sign of the derivative will be determined using the critical points. So what are the critical points? Okay. So the critical points are the points where the derivative is either 0 or it does not exist. So the critical point are x equals to 1. Here the derivative is 0. X equals to 2. Here the derivative does not exist. And x equals to 3. Here the derivative is equal to 0. So now we should be plotting these points on the number line and checking the signs using the test points. So let's draw. So we are having x equals to 1, x equals to 2, and x equals to 3. So the sign of the derivative will be governed by this expression. Now note that when x will be less than 1, this is going to be negative, negative. So the derivative takes positive sign because the denominator as such cannot be negative and 2 is not negative. So negative times negative is positive. When we are above 3, we will note that again the derivative should be positive. Okay. Now suppose we are between 1 and 2. Okay. So if we are between 1 and 2, x minus 1 is positive and x minus 3 is negative. And if we are between 2 and 3, then x minus 1 is positive and x minus 3 is negative. So if we are above 1 and below 2, so this should have been negative. And if we are above 2, below 3, again this should be negative. So you notice that the derivative is taking negative sign on the interval 1, 3. and positive signs before 1 and after 3. So if you talk about the regions of increase and decrease, so if you talk about strictly increasing occurs on the interval 1 minus infinity till 1 union 3 infinity. And strictly decreasing occurs on the interval 1, 3. If you want to just talk about increasing, so you should be including the endpoints. And if we talk about decreasing, you should be including the endpoints 1, 3.